Hi, folks. Welcome back to 7.1, part 4. And so in this video, we're focusing mostly on just doing examples of our verifying identities. All right, so let's get started. Example 11. We're going to choose the more complicated looking side, and we're going to try and make it look like the other side. All right, so I see the sine squared, and one of my natural tendencies is to go ahead and distribute, right? We see something outside of parentheses, we distribute, we get sine squared theta plus sine squared theta cotangent squared theta equals 1. Okay, and so we'll call this algebra. Now, my next step would be to say, let's turn everything into sines and cosines, right? So this is fine, but this I have to change, right? So sine squared theta plus sine squared theta over 1 times, right? And I'm doing the over 1 so that I can sort of prepare for the idea that cotangent squared is going to be a fraction. And in fact, it's going to be cotangent squared theta. Oh, no. It's going to be cosine squared theta over sine squared theta. Now, we want to write the equals 1, but I think it's important for us to make sure we know which identities we're using. So what would I write here? I would write the quotient identity. Okay. All right. Now, looks like I set myself up for success because I noticed that the sine squared and the sine squared, those reduce. And so what do I get? I get sine squared theta plus cosine squared theta equals 1. All right. So I'm going to say this was an algebra step. And now we have one last step. Sine squared plus cosine squared is 1. And so we get 1 equals 1, which is great news for us. But the reason we get 1, let's put a name on that, our Pythagorean identity, right? Our Pythagorean identity allows us to say that sine squared plus cosine squared equals 1. All right, not too bad, huh? Let's try number 12. All right, so this looks a little bit messier, but I noticed that I have a tangent squared on this side, and then over here, I have secant theta minus 1, all right? So here's what I'm going to do. I'm actually going to work with the right-hand side in this case. So I'm going to go ahead and copy down the left side because I always want to write that other side. But what I'm going to do to the right-hand side is I'm actually going to multiply by the conjugate of the denominator. That's going to be my fancy way of saying 1, okay? So I've got cosine theta over secant theta minus 1 times, now I can multiply by 1 anytime I want to, and it doesn't change the problem. So I'm just going to think of the most clever way that I can say 1, which in this case is secant theta plus 1 over secant theta plus 1. Okay? Now, what this means is I'm going to be multiplying those two together on the bottom. And then the cosine, I'm going to multiply times secant plus 1. Okay? All right. We're going to write fancy 1. All right. I know that's technically just algebra, but it's such a common trick that I think it's worth writing out. All right, cosine theta plus 1 over tangent squared theta equals, let's go ahead and work out the numerator. So we get cosine theta secant theta plus cosine theta. So all I did was distribute. And then I'm going to FOIL the bottom. That's going to give me secant squared theta plus secant theta minus secant theta minus 1. Okay. And so we'll just call this algebra. Oops. All right. I know it's a lot of writing, but folks, I do this every year for every class, so I encourage you to do it as well. All right, I'm going to start with the denominator this time. I notice that my secant and secant cancel out, and so I'm left with secant squared theta minus 1 on the bottom, okay? And then I also notice that secant is really 1 over cosine. So I've got cosine theta over 1 times 1 over cosine theta plus cosine theta. All right, and what I've done here is a combination of the reciprocal identity and some algebra. So sometimes we do more than one thing in the same step, and that's okay. Now I notice that this cosine and cosine, those reduce. That makes this whole term equal to 1. So cosine theta plus 1 over tangent squared theta equals 1 plus cosine theta over, so we're going to say that's algebra. Whoa. Algebra. And secant squared theta minus 1. This is so important. I'm going to put a star next to this, and we're going to take a look at this separately over here, okay? So one of the Pythagorean identities that we learned is tangent squared x plus 1 equals secant squared x. But we can move things around in this identity. So what happens if I subtract 1 from both sides? I get tangent squared x equals secant squared x minus 1. What does this mean for us? This means that everywhere I see the tangent squared x, I could replace it with secant squared x minus 1, but also vice versa. Everywhere I see the secant squared theta minus 1, I can replace it with tangent squared. That is precisely what I'm going to do. Okay. Now, we technically have one more step because this is cosine theta plus 1, and this is 1 plus cosine theta. So let's finish annotating. This is algebra, and it's also the Pythagorean identity. But let's make sure we write it exactly the way it is on both sides. And we give ourselves a check mark just because of a little algebra here. Okay. All right, so that is example 12. Example 13. Let's do this one and then we'll probably break for the last video, okay? So here we have a case where it's actually going to be useful for us to look at some algebra before we do anything else, all right? And here's what I mean by that. This is definitely the more complicated looking side, okay? But if we do a little bit of factoring, let's see where that gets us. We're going to keep the denominator the way it is. We're even going to write in the other side over here, just because we know we should be good mathematicians and write both sides. But this is what we're going to factor, okay? Secant to the 4th minus tangent to the 4th. How in the world do we factor that? Let's go ahead and put a little note for ourselves over here, okay? Now, one of the things we might know is that x squared minus y squared factors into x minus y times x plus y, right? A difference of squares. You might have learned that somewhere along the way. It turns out, though, that this works for a lot of different cases. So, for example, x to the 10th minus y to the 10th Well, that will factor into x to the 5th minus y to the 5th times x to the 5th plus y to the 5th. Okay. Or x to the 8th minus y to the 8th factors into x to the 4th minus y to the 4th times x to the 4th plus y to the 4th. So it's not too far of a stretch to say that x to the 4th minus y to the 4th. Let's see, what are we doing to these powers? 10 divided by 2 gives us 5. 8 divided by 4 gives us, 10 divided by 2 gives us 5. 8 divided by 2 gives us 4. So 4 divided by 2 should give us 2. Okay. So this is a really handy pattern for factoring, right? These cases just come up a lot. It's not that I need you to memorize it, but your life is going to be a lot easier if you memorize it, okay? So back to the question. I've got secant to the 4th minus tangent to the 4th. That, my friends, is going to factor into secant squared theta minus tangent squared theta times secant squared theta plus tangent squared theta. All right, so this is just some factoring. Now, I've noticed that a lot of us are definitely learning how to factor. I can see it. I saw it on exam 1. But for some of us here, we really need to make sure we're learning how to factor because it only gets worse if you don't know how to factor. Okay. All right. What do we notice here? This term is exactly the same as this term. That allows us to reduce them to 1. And we are left with secant squared theta minus tangent squared theta equals, oh my gosh, we're already done. The only thing we needed to do in this particular question was algebra. We didn't even use any trigonometry. We just used algebra, okay? So that is the power of having algebra at our fingertips, right? We can make things happen so much smoother, so much more quickly than if we didn't know that algebra piece, all right? So we're going to stop here for this video. Come on back for the last installment.